I mean, the climate system is can change much more quickly than people realize. So that's, I think, a key message, and we're seeing that in Antarctica.
Well, hello, and welcome to another Climate Emergency Forum. I'm Herb Simmens, the author of A Climate Vocabulary of the Future, and I'll be your host. This week, we're diving into a very sobering new study published in Nature. Our program is really called Antarctic Sea Ice, a New Climate Tipping Point. Basically, this study reveals that Antarctica, once thought to be a frozen, unchanging stronghold, is now undergoing rapid and indeed alarming transformations. So, sea ice is shrinking at double the rate of Arctic ice, ocean currents are slowing, and the ice sheets, especially in West Antarctica, are nearing tipping points that could lead to over 5 meters of sea level rise, threatening the 750 million people living in low-lying coastal areas worldwide. Ecosystems from penguins to marine life face collapse under warming temperatures and unreliable ice conditions. I guess sadly we can't be surprised that we now have to apparently add Antarctica to our list of major ecosystems at risk. It seems there are few, if any, major ecosystems anywhere on this planet that are immune from transformation or even collapse. So basically, we have with us, as always, our colleague Paul Beckwith. And Paul, as you know, is a climate system scientist from Ottawa who's host of a very popular YouTube channel with well over 1,200 programs covering every aspect of the climate change. And so we're going to ask Paul, who has looked in particular at this paper, to tell us what are the key aspects, what do we need to know, and what, if anything, can we begin to think about doing about that? Before I turn it over to Paul, though, I just want to say once again, as with a recent program, at the end of the program, we'll have a brief summary of some of the key news that's occurred in the last couple of weeks or so. So make sure you stay tuned to the very end. And with that, happy as always to introduce Paul. Paul, the floor is yours.
Thank you, Herb. So this new peer-reviewed scientific paper on Antarctica is arguing that there's a major regime shift or phase transition or tipping point has been crossed regarding the sea ice surrounding Antarctica. So up until about 2014 or so, the sea ice around Antarctica was increasing roughly about 1.5% per decade, and that included ice during the maximum sea ice extent, of course, in the southern hemisphere winter, and the minimum sea ice extent in the southern hemisphere summer. Since 2015, it's dropped off a cliff. And actually, the losses of Antarctic sea ice in both the summer and winter in Antarctica since 2015, so in the last 10 years, the loss of sea ice has exceeded that we've seen in the Arctic over the last 4 decades or so, 4.5 decades. So we've all been concerned about the Arctic loss of sea ice because, of course, this makes the Arctic darker. It absorbs more sunlight. Therefore, the temperature rises much faster rates than the global average, about 4 times faster, 5 times faster, depending on the latitude. The higher the latitude, closer you are to the pole, the faster the warming rate. This is known as Arctic temperature amplification. Antarctica has been a separate beast. It's kind of been isolated from the rest of the climate system. It was thought to just be stable and be there and have no major changes for decades to centuries. And we're finding out that the climate system is capable of extremely rapid changes, abrupt changes. And we're seeing that in Arctic sea ice. And it's not just affecting the local marine life and region, but it actually has long reaching effects on the entire global climate system. via the ocean currents in particular.
How surprising is this finding? Is it almost inevitable that we would sooner or later discover this, or is this something that the authors of the paper are really kind of shocked or deeply surprised to have encountered or discovered or through their analysis?
I think the vast majority of scientists have been completely shocked and surprised at what's been happening. It wasn't captured in any of the models and so on. And, we've often talked about how the melting sea ice and changing conditions in the Arctic has slowed the ocean currents. And, people have been concerned about an AMOC, the Atlantic Meridional Overturning Circulation collapse. What we've actually seen in the last, since 2015, is a huge slowdown in the Antarctic meridional overturning circulation. Sometimes it's called the SMOC or Southern Meridional Overturning Circulation. The paper that was just published a couple of weeks ago calls it the Antarctic Overturning Circulation, the AOC, basically. But anyway, it's slowed down as much as the AMOC has, but it's done it again in a shorter period of time, less than 10 years. It has huge ramifications to the overall climate system because we need the water descending from the surface to the seafloor because it carries carbon with it. It's a primary reason the oceans act as a large carbon sink, and about half of the CO2 that we emit by industrial activities, land use changes, it gets captured in the ocean, and a lot of it then goes down to the seafloor where it's sequestered. So the carbon sink starts to fail and greatly reduce when the ocean currents taking the carbon to the seafloor halts. Also, of course, surface water is highly oxygenated. It exchanges oxygen, absorbs oxygen with the oxygen in the atmosphere. So that water, that oxygenated water, no longer makes it to the seafloor. So this is catastrophic for benthic marine creatures, anything living at the bottom of the ocean. Also, a lot of salt is carried down there because the saltier water, when ice forms, the sea ice forms, it rejects salt, about half the salt right away. The rest of the salt trickles through the sea ice over time, entering the ocean in these brine cavities through the sea ice. So eventually the sea ice becomes fresh enough if it survives long enough. So the salt is carried to the ocean floor. So the salinity balance of the ocean changes as there's less overturning. And also nutrients come up to the surface when deep ocean water rises, and that's vital for marine life on the surface. So when we get a more stratified ocean and less vertical mixing, then we can eventually perhaps head to a state known as the Canfield Oceans, which is basically a dead ocean system with very little vertical mixing. We're in a dire situation as we find out more and more about the climate system and how it's changing. We should becoming more and more concerned, but the public understanding doesn't seem to be there. So I think our job is very important to try to educate the public on what's happening to the climate system.
Yeah, I wonder though, isn't it at least generally true that scientists are reluctant to reach any firm conclusions unless there's confirming papers or confirming research? This is, from what you're saying, the first such paper to come up with these findings, and they are alarming. Should we wait? I don't mean to suggest we should be complacent. And I don't even know what wait means because we're not doing a whole lot anyway. It's not as if we're super engaged in climate mitigation. But maybe another question to put your sort of projection hat on, Paul, is what's the likelihood that maybe another group of scientists might find a less alarming conclusion when they take a look? For example, if we look at the AMOC, there are all kinds of papers, and I'm not a
Right.
scientist, as you know, but the papers range from, a high likelihood of it collapsing to mid-century till, to the other extreme, which is that it's probably going to be in reasonably good shape for another century or two. What's the level of certainty that we should have about this particular paper?
The level of certainty that we should have, the best way to answer that question is look at the graph of Antarctic sea ice over time. So from 1970s on, we have satellite data. We can go to proxy data, ice core records, various places in Antarctica and bracketing it, go back 100 years. We can look at ocean floor sediments, go back 300 years. And any person looking at those plots would say, hey, something's broken in Antarctica. You could show it to a grade school class and say, look at this curve. Does this mean anything? It's basically dropped off a cliff. So I think that something is broken in Antarctica. We know that with 100% certainty. So of course, there'll be lots of science coming out about it and on the ramifications and effects. But I think it's clear to any logical person that there's a regime shift or something is broken, something has changed in sea ice around Antarctica. And then you have to ask, well, how does that affect the ice that is sitting on the land, which is capable of greatly increasing sea level? You also have to ask about with these changing reduction of overturning circulation, how will that affect the carbon sink in the southern oceans? How will it affect nutrient distributions? How will it affect marine life? And all of these things, you can come to a logical conclusion. And it does surprise a lot of scientists. But if you look in the paleo records, if you look at large shifts of Earth's climate, many of them are related to rapid changes in the ocean current system, right? We know this from the Younger Dryas, the AMOC shut down and restarted 1300 years later. We have a lot of information on the ocean currents in the northern hemisphere and how it affected paleoclimate. The 8.2 K blip cooling, the AMOC shut off for 130 years. In the Dansgaard-Oeschger oscillations were an AMOC shut off, followed by the ice calving events, Heinrich events. We know all this was going on, but when you read about how these things happened in the past, we have very little information about what happened in Antarctica when the Northern Hemisphere AMOC shut off. So we're getting more information. This paper showing the Antarctic meridional overturning circulation reduction since 2015 and the sea ice and stuff. I think it's a real eye-opener, and I can guarantee you that strange things were happening with Antarctic ocean currents when they were happening in the Northern Hemisphere in our records. So it's just our lack of information on Antarctica. Often we thought that the AMOC slowing down, shutting off, maybe the Antarctic meridional overturning circulation would greatly increase in strength to compensate. But here we have a case, we have definite proof that both systems are slowing down significantly, and the Antarctic system is doing it at least 4 or 5 times faster than the changes in the Arctic. I think this should be the biggest climate story of 2025 for sure.
Well, let's hope in the last 4 months of the year we don't have a bigger one, since almost all the climate stories are bad news. This one's bad enough. So it sounds like the bottom line from what you're saying is, notwithstanding the fact that this is, the first paper to sort of put this together the way it has, there's a high degree of confidence that you're expressing that its recommendations and conclusions are valid enough and reliable enough and backed up by enough data that we should, at least provisionally take them as, likely to be the case, and to ignore them would be at our own peril by humanity. So the next obvious question, I guess, that a lot of people would have is the sort of the so what question, or maybe more accurately, the so when question. What does this paper say, if at all, about when and how fast sea level rise will increase, or some of the other negative consequences on to humanity and the larger ecosystems around the planet? Is this something that we don't need to worry about for millennia, even if it's now inevitable? Or is this something that, while it may not be like the disaster movie The Day After Tomorrow, is this something that we need to worry about, let's say, in this first half of the century?
I would argue that if present trends in Antarctica continue, we're very likely to have what I've coined a blue ocean event, where there's less than 1 million square kilometers of sea ice in Antarctica within 10 to 15 years. and it's much more likely than seeing such an event in the Arctic at this stage based on the trends of the last decade. Of course, if things turn around in Antarctica and there's some stabilization of the situation because of some effect that we don't know about, then we'll have to reevaluate. But the trends in Antarctica, I think, will become quite visible to the entire world via, disruption of climate patterns, disruption of the intertropical convergence zone, disruption of rainfall patterns, monsoons, and it extends across the planet. It's not, I have to say, what happens in Antarctica doesn't stay in Antarctica.
You're saying in the next, am I hearing you right, that the consequences may begin to be felt as soon as the next 10 or 20 years or so?
I think the consequences to the atmosphere and to weather patterns, the jet streams, and extreme weather events will be seen in the next, certainly within the next decade.
Wow.
10 to 15 years, 10 to 20 years. I think the effects on ocean parameters will take a bit longer because there's more of a lag time in the time it takes for something to be translated from one location in the ocean, a big change to another. However, let me note already one of the big climate effects of this, what's happening in Antarctica in context with the Arctic is that less heat going to the poles by the ocean currents means that more builds up at the equator. It means that there's actual shifts of the monsoonal patterns, the intertropical convergence zone, the band of rainfall. And that band of rainfall has started to shift already southward, and winds associated with that phenomena actually push upwelling of cold water to Panama. Okay. And it's very important. It keeps Panama a bit cooler than it would be otherwise, the colder water. Well, reports have just come out in the last few days that for the first time in 40 years, that system has failed. The upwelling of cold water to Panama did not occur this year for the first time in 40 years. So I immediately started to, look for connections and wonder what was going on. I think it's the northerly winds that push the water. Northerly winds are from the north, right? Westerlies are from the west. So northerly winds from the north, they push the surface water away from the Isthmus of Panama. And that water then has to be replaced by upwelled water, which is from deep down and cooler. But those winds have really weakened, and that didn't happen this year. Therefore, there was no upwelling of cool water off Panama. So that's just one example. There's far-reaching effects, and all these things are somewhat connected. But, how are they connected? The devil's always in the details. But I think we're going to see a lot of strange things like that happen. I mean,
Well,
we're seeing chaos in social systems, in law and order, on the geopolitical front, right? I mean, we may as well because we're seeing chaos and complete disruption in the climate system, and they're not independent of each other, in my opinion.
well, you're illustrating what we've often said here, harder sometimes to demonstrate, which is how everything is connected to everything else. A narrow focus on one dimension of the climate system is almost guaranteed to be misleading or incomplete and lead to maybe even the wrong remedies. So, you're saying that should begin or likely to begin to see the impacts of sea ice loss as described in this paper in perhaps a decade or not much longer than that. Does that also include sea level rise? Does that mean that those of us who already are concerned about selling our properties near the shore need to call our realtors soon? Paul, what's the prognosis for sea level rise from this paper?
Of course, sea ice is floating. So when the ocean water freezes and forms the ice, or when the ice melts back into the ocean, surrounding ocean, that doesn't directly cause sea level rise, of course, right? It's like, you have a glass of ice water, and when it's filled to the brim, and when the ice melts, it doesn't cause the water to overflow in your glass, right? But there are many other effects related to the loss of sea ice. So around Antarctica, the loss of sea ice means that the glaciers on the land can flow more quickly. It's like taking a cork out of a bottle. If you don't have fast ice, which is ice locked to the ice shelves, and if you've got sea ice, you can get warmer water getting closer to the ice shelves, and most of West Antarctic ice sheet is grounded on bedrock well below sea level. So if you don't have the sea ice, the water can warm, the surface water can warm down several hundreds of meters. That water can go under the ice and melt the ice on West Antarctic from below at faster rates. The shift in the a reduction of the downwelling of the water to the deeper ocean can mean that warm water can more collect at the surface and again undercut the ice shelves. And all of those things increase sea level rise. Of course, if the ocean currents slow down, think of the Gulf Stream carrying all that heat in the northern hemisphere over to Western Europe and the Arctic. If that slows down, then that water will start piling up on the east coast of the US. So an AMOC shutdown would raise sea level. The models show up to 2 feet on the east coast of North America. And if the shutoff of the ocean currents occurred in, say, a decade or less, that would raise sea level those amounts 2 feet in a decade or less. So we're talking about massive increases very rapidly. You have to look at the overall system to really see. But the other thing is if the AMOC shuts down, up to now we've thought that the heat would, of course, concentrate in the tropics and in the southern hemisphere. And we believe that sea level would rise at much faster rates because we wouldn't lose ice anymore from Greenland, right? It would go much colder, but we would be overcompensated by the additional losses from Antarctica. So we think, if you look when the AMOC shut down in the past, we've had very rapid sea level rise events. There's meltwater pulse 1A. There's periods when sea level has risen much, much faster than it has today. It's risen at, rates that are 10 times, 20 times faster than today's rate of sea level rise increase. So again, it's the overall system that changes. Sea ice is just starting the process. Most people, 90% of people live in the northern hemisphere. Our ice core records are extensive over Greenland. The meteorologists and climatologists live in the northern hemisphere and have studied, what's happening with the AMOC and jet streams and stuff in the northern hemisphere, the polar vortex. There's comparatively only a fraction of that knowledge and research studies being done on Antarctica. Again, Antarctica was thought to be a very stable, unchanging place, and now we're seeing that that's not happening. So people are scrambling, led by Australian scientists, of course, being the closest ones to Antarctica. There's more and more changes going on in Antarctica. There's more and more cruise boats visiting the shores. There's more and more scientific research vessels going down there. The geography is quite different, of course, between the two hemispheres. We don't have something like the Gulf Stream equivalent in the southern hemisphere, right? There's ocean completely surrounding Antarctica. You can completely go around the planet without hitting land. The Arctic is basically the Arctic Ocean encapsulated or surrounded by land, right? So when we lose Arctic sea ice, it's very, very close to the North Pole, right? When we lose Antarctic sea ice, it's at much lower latitudes, right? Because we've got the whole Antarctic continent and the sea ice that forms around Antarctica, the latitude it's much further away from the pole, much, much further away from the pole than Arctic sea ice. So loss of an equivalent amount of Antarctic sea ice, the albedo effect is much stronger. The sun is much stronger because you're not right on the pole. So the effects are much, much larger. So that includes the effects of the ocean current changes and so on. But we have stronger winds and stronger circumpolar currents around Antarctica, which again isolates it. So we don't have as much heat being carried by the oceans down to Antarctica than we do being carried by the ocean currents in the northern hemisphere carried up into the Arctic. So the situation is quite different. And I could go on for a few hours on this topic, but I think I've pointed out the key differences.
Okay, thanks, Paul. I guess it's fair to say that this new paper is changing once more how we look at climate change and how we have to respond and what the risks are for all of humanity and the natural world. We can only hope and expect that climate scientists will step up and accelerate their research to address what you're talking about, Paul, about the absence of the kind of data and deep investigations of the Antarctic that we've had of the Arctic. We hope that the pullback in the United States won't affect that level of research. So hopefully other governments and organizations can fill any gap that the U.S. in one of the largest acts of scientific vandalism in human history are perpetrating on the planet so that we can begin to get this vitally critical information and monitoring and analysis so that we can prepare as best as possible for these changes that you have so eloquently and comprehensively today articulated, Paul. So I want to thank you, Paul, for giving us this really important update on a critical paper. And as I mentioned at the beginning, I wanted to spend a couple minutes with some sort of brief news snippets that I've uncovered or looked at in the past couple of weeks. This, of course, is just a tiny a fraction of all of the news about the climate crisis. So in Italy, they have what's called a Certified Tour Guide Association, and they have called for a rethink of the summer opening hours at major attractions in Rome, citing climate change after a tour guide died of a suspected heart attack while showing a group around the Colosseum in baking heat. Just one example of the knock-on consequences of climate change that we're beginning to see. Some of you may have read about the fact that a consortium organized almost spontaneously of many U.S. climate scientists have written a detailed rebuttal to the Trump administration's effort at minimizing climate science through a recent report. And I just wanted to quote the climate scientist from Texas, Andrew Dessler, about his motivation. And he said, "I did not go into science to make money, nor did I go in to push a liberal agenda. I went into science because I love science. I love the rigor. I love looking at data. More importantly, I respect science. When I read the Department of Energy report, I saw a document that does not respect science. In fact, I saw a document that makes a mockery of science. And I thought to myself, I cannot let this go without a response. So that's why I've spent a huge amount of time in the last month when I should have been working on my classes, putting these comments together. And these comments point out about 100 misconceptions and falsities in the report that the Trump administration is attempting to use to justify closing down action on climate science. Another small but important scientific research conclusion, the global nonpolar ocean absorbed about 10% less carbon dioxide than expected as sea surface temperatures reach record highs in 2023. And as you said earlier, Paul, about all the things that are happening that are disasters that we don't hear about, and I came across one that particularly shocked me, and that is that a mountain village of more than 1,000 people in Sudan's Darfur region has literally disappeared in a landslide triggered by weeks of rain, according to locals and the rebel groups that control the area. And they have found, and it sort of reminds me of that flight in India that crashed, one survivor out of 1,000 people. And otherwise, the village is off the face of the earth. But because it's in Sudan, no one knows about it, but the level, obviously, of suffering and harm is almost too hard or too much to anticipate. So these are just a few of the kind of clips from this past week or so. Last, I just wanted to mention that we had on Rob DeLay and Peter Bunyan a few weeks ago from Exeter talking about their plan to cool the climate by reforesting the Amazon. And a new study came out that was just on the front page of the New York Times yesterday, as we're recording this, saying that for decades, the dry season in the Amazon rainforest has been getting drier. A new study published just this week that we're recording this found that about 75% of the decrease in rainfall is directly limited and linked, rather, to deforestation. And therefore, it reinforces what Rob and Peter said in our conversation with them about the enormous potential at reforestation and avoiding deforestation. So there's a few clips. Paul, thanks so much for giving us so much insight on this critical new study. As always, if you like this program, then do like it and subscribe to our channel. Press our notification button. Tell your friends and colleagues about the Climate Emergency Forum. Go to our website, climateemergencyforum.org, and we'll be back as always after 200 programs with another program in this coming week. So have a good week, everyone, and we will see you soon. Bye bye.